So another property of wave we are going to talk about is the next one here, which is polarization. Polarization. So let's talk about polarization. When we say polarization, in simple terms, we can say that polarization simply means making a wave to vibrate in a single plane or direction. So whenever we are trying to make a wave to vibrate in a single direction or plane, it is called polarization. Now let me give you an example. Whenever a wave is emitted, for example, the light coming from a bulb, whenever you put a bulb inside a dark room, you see that the light from that bulb, which is the waves from that bulb, they will travel in all directions. They will split out in all directions. Now, but what if for experimental purposes, we only want the wave that is moving in a particular direction? How can we achieve that? We can achieve that using the property of what? Polarization. Okay? So usually, a device that you can use for polarization is called a Polaroid, or sometimes it is called a polarizer. A Polaroid or a polarizer. So what happens? If I have unpolarized lights, so look at unpolarized lights from a source. So this diagram is just like the diagram I drew before. So I have an unpolarized light, and then I pass this unpolarized light through a what? Through a Polaroid. I pass it through a Polaroid, something that will make the light move in a particular direction. Okay? So if I pass it through a Polaroid, you see that the Polaroid will absorb other part of the light and only vertical light will come out. So this guy is unpolarized. This is unpolarized and this is polarized. So polarization simply means making the wave to vibrate in a single plane or direction. That is what polarization is. Now, this property of polarization is very, very important. Why is it important? Because we can use it to distinguish between longitudinal and transverse wave. Remember, we have talked about longitudinal and transverse wave. So we said that longitudinal waves travel parallel to their source and transverse wave travel perpendicular to their what? Source. So the property of polarization can be used to distinguish between the two types of what? Waves. Now, looking at this now, since we know that polarization can be used to distinguish both of them, you should know that only transverse waves can be polarized. Only transverse waves can be polarized. Longitudinal waves cannot be polarized. Longitudinal waves cannot be polarized. Transverse waves can be polarized. Longitudinal waves cannot be what? Polarized. That is one thing you must know about. Longitudinal waves are not. So in JAMB, you might see a question like, how or which property do we use to distinguish between sound and light? You can see that kind of question. So when you talk about sound, sound is longitudinal, light is transverse. So you can use the property of what? Polarization to distinguish between both of them. Okay? Take note of that. Then finally, on properties, we talk about interference. So when we say interference, what does it mean to interfere? What does it mean to interfere? So when you say interference, interference simply means to what? To disturb. So imagine you are trying to disturb somebody doing something. That is what interference is. But how do we define interference in waves? So we normally say that interference in waves is, or we say that interference occurs when two waves of equal frequency superpose. When two waves of equal frequency superpose. Now you can also use collide here for me. You can also use collide here for me. Okay, so when we say superpose is mainly used for waves when they collide. So when two waves collide together, it is called superposition. Now, interference occurs when the two waves have equal what? Frequency. Sometimes you will see it as nearly equal frequency. So it can be equal frequency or maybe nearly equal what? Frequency. So imagine when something like this occurs, we call it what? Interference. Let me give you an example. Of interference. Now, usually, waves what? Collide Okay, waves are always in collision. So for example, let's say that Mr. A is making a call. Let's say that Mr. A is making a call to let's say to Mr. B, and then Mr. C is making a call to Mr. D. Now what happens? You see that during their motion, the waves might collide with one another. Okay, they might collide with one another, but because they are transmitted at different frequencies, they would not disturb each other. So the wave coming from Mr. A will just go, and then the wave coming from Mr. C will also go. So both of them might collide, and then as they collide, they will just be going their own separate direction without interfering with one another. Okay, they will just be going through their own business and all that. Now, but on the other hand, if the frequency of the wave of Mr. A is the same as the frequency of Mr. B, both of them will now get confused. Okay, they will now confuse each other. So imagine that Mr. A is saying hello on his own end, and Mr. C is saying how far on his other end. These two things will now join together depending on how they interfere, and they will get to their various sources, and the person will be confused. Okay, let's imagine that Mr. A was talking about a particular stuff, and Mr. C was also talking about another different stuff. These two things will be coming to their recipients. You see that it is going to be confusion. Okay, it is going to be confusion. So that is why our mobile phones, of course, whenever every person is making calls, so if everybody in the world is making call, you are not transmitting at the same frequency. Of course, it's not going to be possible for everybody to be making call at the same time. When you're making a call, a particular frequency band is assigned to you, and that is how it happens. So when you're done, you release that frequency band for someone else to be able to use. Now, so whenever this kind of things happens, it is called interference. So the only time both waves will know, or they will interfere with one another, is when they have equal frequency. Okay, so that is that about properties of waves.